exercise 9C using a financial solver to analyze reducing balance loans. We have established so far that we can use sequences and we can also use amortization tables to be able to determine payments and how long different payments can take. And the joy of spreadsheets is that we can automate that process. However, it is still quite long and still very challenging to do, and sometimes we just don't have the time to get this done. Well, we've got an even more powerful tool to be able to calculate specific loan amounts and so forth, and that is using the financial solver. The financial solver is under the financial section in the CAS, which is the same place that we went to go and convert interest from nominal to effective. But instead of pressing interest conversion, we go and select another option. So in the CAS, we have and when we go into financial, you might notice that your interest conversion one from last chapter is still up there. We're just going to go and clear all. And what that does is that gets us here to the menu. So the option we need to go and choose is compound interest. Fun fact, you're going to be using this option or interest conversion, and pretty much that's it for further maths. This is the main one that you'll be using. You've got lots of different options here. The N at the top is the number of periods. So for example, if we've got a 3-year loan or something along those lines, but we're compounding monthly, we would need to do 3 times 12. If you're having a loan over 20 years and it's compounding weekly, yes, it will be 20 times 52. I percentage, you could possibly guess, means the interest rate, and that's just the ordinary yearly interest rate. You don't need to do any calculating or any dividing or anything like that. Just put the yearly interest rate, the nominal interest rate. The PV is principal value. Principal value is whatever the original amount of the loan that I need to go and borrow. PMT is the payment. That's the regular payment that I have to make each and every time. FV is the future value. So often we will try to set that to 0 if we know that we want to find out how many years it will take to pay off a loan. But often that is the final answer. Sometimes the question is, what will be the value when ... and we'll click on FV. You'll see under PY and CY, these are usually the same number for further maths, and they're payments per year and compounds per year. We tend to do the same number of payments as we would compound. So if we're doing a compounding weekly, we're doing 52 payments. So we'll put 52 and 52. If it's quarterly, we're going to be paying quarterly. Rarely do we change these. I don't think there's any instance where I've seen where we've changed these values. So the last 2 numbers there should always be the same. When entering data, be aware of a sign convention. So what this means is that we use positive numbers and negative numbers in the payment section and the PV section. So just as an idea there to remember which one's which, because having a minus or a plus does affect what answers you get. If the bank is giving you money, if that's something you're receiving, the number in the calculator should be positive. If it's something that you're giving back to the bank, then it is negative. Example 9C.1. Andrew borrows $20,000 at an interest rate of 7.25% per annum compounding monthly. This loan will be repaid over 4 years with payments of $481.25 each month. A, how much, correct to the nearest cent, does Andrew owe after 3 years? So what we're going to do is we're going to use the financial solver, and what I'm also going to suggest is to show you what would be acceptable working out to present in an exam or in a SAC, and that is to write out the entry points that you would put into the CAS. So what I'm going to do for A, we want to find it after 3 years. So I'm just going to put A here. I'm going to write, and what I'm going to do is I'm going to enter everything accordingly. So we want it after 3 years. So we know that it's compounding. Well, let's go and put N, it's 3. But now it says that it's compounding monthly. So that means the N has to be multiplied by 12 And we need to put a 12 and a 12 down here at PY and CY. So 3 times 12 is 36. The interest rate here is at 7.25%. So I'm going to put 7.25 here. The principal value is that 20,000. The PMT, the payment, is this $481.25, but that is the amount that I'm paying the bank. So that has to be a negative number. If I'm doing the paying, that is a negative sign, because that's the minus D value. If you remember from 9A, where we had to make a regular repayment, and that was minus D, that's what this payment is. It's the minus D there, 25. Whereas the $20,000 is the amount of money that I was given from the bank, so that's going to be positive. So the only thing we don't know, so the final answer is the FV. So the FV is our final answer. So what we're going to do is we're now going to enter that into the calculator accordingly. Now, fun fact, if you don't trust your arithmetic skills, you can actually put in the operation into the calculator. So I did 3, and I did 3 times 12. It'll do that for me there. So then 7.25, 20,000, and then negative $481.25. 12 and 12. And then what I do, whatever value that I'm looking for, I just press the button here. So you see how I'm pressing FV, I release, and that is telling me how much that I still owe after 3 years. So after 3 years, I will still owe $5,554. Please don't write negative $5,554. So Andrew owes $5,554.36. He doesn't owe negative, because that's 2 negatives then. He's owing and owing. That doesn't make sense. So he owes $5,554.36. B, what final payment amount Andrew must make to fully repay the loan after 4 years? So let's find out how much much money he does owe after 4 years by just changing one small thing about our entry. So instead of n equals 36, I'm just going to do 4 times 12 and then get the final value. And you'll see there that it's come up with 0.10792. So you'll notice that's a positive number. So the positive number means the bank would be giving Andrew, he would be in credit of rounding up 11 cents. So rather than the bank going, thank you for giving me your payment, here's 11 cents back. No, what he will do is he would shrink down the final payment there, that $481.25. And so for B, what he would do is he would take that $481.25 and minus 11 cents from there. And so the final payment would be $481.14, like so. Now you could also still set this up as a sequence, that is fine. And you would just set up a recurrence relation where you would use RVN minus D. However, using the financial solver, because usually you end up just changing one thing or 2 things, gets you instant answers. So whatever you wish, that is fine. I personally prefer the financial solver.